Hello, Nicole Mashburn here, and we are going to continue on with our skin discussions, and this is what I call more on skin. So you've kind of gotten the basics on why we have skin, what its function is, why we have it, the layers of it, where it looks like the epidermis, the dermis, the hypodermis. So now I'm going to kind of give you some extra stuff, kind of some things that are interesting about the skin, and then I'm going to do another talk on skin disorders, because it seems like everybody has some kind of something going on with their skin. So we'll get through this talk, and it won't take too long. It's not that long of a talk. Hang on just a second, because I got to get my pen. Let's do red. Okay, more on skin. So you've already figured out, like I said, you've seen the epidermis and the dermis and the hypodermis and kind of know what's going on there. Well, we have skin markings. Our skin has some different markings, and we call those friction ridges, and you probably know them as fingerprints. And basically, that's, if you looked at the skin, you had the epidermis, and you had the dermis, and you had those papillary, those dermal ridges, where the epidermis and the dermis kind of make the wiggly papillary area like that. Where these ridges form, that makes the friction ridges or the fingerprint. So let me go ahead and get a picture. So this is a blown up view of the palm of someone's hand or a fingertip. And so this is actually, if you were to take a cross section and turn the skin sideways, you would see that what you were seeing were these dermal ridges, and everywhere that you see the kind of top of the ridge, you're seeing these fingerprints. You'll also see there's little bitty openings, and those are openings for sweat glands. So, you know, when you get nervous, you get sweaty palms. You actually do, because there are sweat glands there, so that you can sweat on your fingers and things like that. So when you leave a fingerprint, what you're leaving is basically the little moisture droplets from the sweat glands on these dermal ridges. So that's how they get a fingerprint, because you're basically taking a picture of your sweat pattern that you left from your when you touch something from your finger. All right, so how do we get skin color? We know there's all kinds of different colors. There's people that are very fair skinned, very dark skinned, have more of a reddish tone to their skin, maybe more of a yellowish tone to their skin, and there's different things that are responsible for that color. There's basically three main pigments that give us color. The first one is melanin. And melanin is basically a pigment that we produce. Our melanocytes, the cells called melanocytes, make melanin, and that actually gives color to our skin. Your skin color is based on the darkness of the melanin pigment, not how many melanocytes you have. Okay? So we all have the same number of melanocytes. My melanocytes make a melanin that's kind of a golden brown color, because I can get a pretty good tan. Okay? If your heritage is more African, your melanin is very, very dark, so your color is going to have a darker skin tone. Native American is going to be more of a reddish color. So you think about the different ethnicities and the different colors. That's the shade of melanin that those people produce. Not the amount of melanin, just the color, the shade of that melanin. So again, it can be anywhere from a yellowish color all the way to a brown or black. If you're an albino, you don't make melanin at all, so there's a lack of melanocytes. They don't make the melanin, or the melanocytes don't work. If you have a mole or a freckle, that is just a local accumulation of melanin. So you kind of have some melanocytes kind of huddle up together, and you've got a lot of melanin there, so it shows up as a freckle. So melanin is one way that we have skin color, one pigment. The other two are keratin and hemoglobin. And you're going, what's keratin? Well, keratin comes from our diet, so think of a carrot, okay? That's where we get keratin from carrots. It is a yellow to orange color, and if people eat a lot of orange vegetables like carrots, sweet potatoes, things like that, it can actually accumulate in their palms and soles, and you'll actually see an orangey color to their skin. If you've been maybe feeding a child, and when you're trying to introduce them to new foods, a lot of times you'll try one food at a time. Or maybe you've got a really picky eater, they just like to have one kind of food. My daughter loves carrots. At one time, she doesn't now, but at one time she liked yellow foods, and you could kind of see a yellow color to her palms when she would eat a lot of yellow foods. So if you have a healthy diet, it really does help to eat your vegetables. You are what you eat, so the yellowish color to your skin can come from the keratin from the carrots that you eat. The last one is hemoglobin. And hemoglobin is the protein that's inside your red blood cells that holds on to the little iron molecule. There's an iron molecule inside of hemoglobin. And hemoglobin and iron bind to oxygen, and that's what carries oxygen throughout your body. So inside red blood cells you have hemoglobin. Hemoglobin has iron. Iron binds to oxygen, and that gives it a red color. And the reason is, think about taking something iron, like an iron nail, putting it outside, and it oxidizes, or oxygen binds to it. Well, it rusts. What color is rust? Kind of a reddish color. So basically what happens is the iron and the oxygen bind, and you basically have rusty colored blood. Well, your skin is kind of translucent, especially fair-skinned people, and so the pink that you see in people's skin, especially fair-skinned people, is actually the red of the blood. And if you don't believe me, take your fingers, hold them up to the light, and you can actually see the red blood between your fingers. And you'll actually get your coloring from the blood. Think about if you get embarrassed or when you get flushed. Your cheeks become red, that's blood, and that gives you color to your cheeks. Now there's other ways to get color. You can become blushing or pale, and I just talked about that. If you blush, that means your vessels are vasodilating. You're sending more blood to the surface of your skin, and it looks kind of reddish. If you're pale, it means your blood vessels have vasoconstricted, so less blood's going to the skin. You kind of get that washed out pale color. Think about especially little kids when they get so cold and their lips turn blue, because they've vasoconstricted, the blood's not in their lips, and they have that blue color, which is not to be confused with cyanosis. Cyanosis is a blue tint that you get when you have a low oxygen level. So a lot of times you'll see this in elderly people, maybe with emphysema or some kind of a breathing problem. They're not exchanging their gases very well. They don't have enough oxygen in their blood, and so their blood's not rusting. You don't have that red color, and they have a bluish cast to their skin. Another way you can see changes in color to skin is called jaundice. There is something called bilirubin in your liver. So usually jaundice is a liver problem, and usually it gives you a yellow cast to your eyes. You'll see this in people, maybe an alcoholic who is finally going through cirrhosis and their liver is failing, and you'll see their eyes start to become yellow, and they're building up this yellow bilirubin pigment and causing them to be jaundiced. It's also very common in newborns. Their liver hasn't turned on yet. They've just been born, and they start to have a buildup of bilirubin, and their liver doesn't know how to deal with it yet, and so it accumulates in their skins. A lot of times children, newborns, will have a yellow jaundice color. Usually it's not a big deal. You just put them outside or put them by a window, and UV light will break down the bilirubin, and their color will go back to normal. Now, if it doesn't do that within a day or two, they may bring out a Billy light, which it's like a UV light that they shine on the child to break it down. If that doesn't happen, you may have to put them in the hospital, but usually it resolves. It's not that big a deal. And then last but not least, you can get a tan. And basically, a tan is just your skin's response to UV radiation. And what happens is, we have those simple squamous epithelial cells, and you've got these melanocytes. Well, these melanocytes have a nucleus, all right? And they make that melanin. And what melanin does, it actually acts like a little umbrella. This is the melanin, and the melanin will actually kind of, for lack of a better word, float over the DNA, over the nucleus, and kind of shield the DNA. So melanin is your body's way of trying to protect your nucleus, your DNA, where your genes are, from UV radiation. So the more you tan, the more melanin you make, and the more melanin you have, the more like an umbrella you start to form to try to protect the underlying cells and their DNA. So it's really a defense mechanism. So that tells you, from that UV radiation is not good for you. You don't want to tan. It's actually not a healthy way. It tends to cause mutations and skin cancer. So So even though it looks pretty, you really don't want to tan. Alright, now there's several things that we call appendages of the skin. So these are things that are kind of extra parts of the skin. And we'll talk about those. We'll do a lab video. We'll go over this in the lab video as well. But the ones you need to know about are the sweat glands, the oil glands, hair, the follicles associated with hair, and the nails. Now we have two types of sweat glands. We have sweat that makes just your normal sweat, the kind that when you're hot. These are called eccrine sweat glands, and you have those on your palms, on the bottoms of your feet, on your forehead, and just about everywhere. Everywhere on your body you have these kind of sweat glands. So when you're hot, you sweat to cool off. You may sweat when you're nervous, things like that. And this sweat is mostly water. It's the salty sweat. Okay? So think about it, when you get really hot, you just kind of lick your lips and the sweat's falling down your face. It's a salty sweat. It has some antibiotics to it. It's got some dermatitis. It's kind of tries to keep your skin clean. It does have some protective value to it. It'll help it can wash away waste and things like that and help cool you off. For sweat glands to work, you have a duct. So here's your skin. You have a sweat gland. The sweat goes out the duct to a pore to the top of the skin. And basically we use them for thermoregulation. So here's our cross section. Here's our skin. And these are your eccrine sweat glands. So you have an eccrine sweat gland, it makes the sweat, and it goes to a sweat pore. And this is what it looks like histologically. Looks kind of like the simple cuboidal cells that you saw in under tissues. It looks very similar to those kidney cells that we looked at when we did the histology of simple cuboidal. So you may see something like this. And these are the eccrine sweat glands. And you'll notice they're not associated with the hair. That's very important. Eccrine sweat glands there's no hair associated. They don't have to be near a hair. Think about it. Do you have hair on your palms? No, but you have eccrine sweat glands there. Now the other kind of sweat gland is called an apocrine, or apocrine, however you want to say it, sweat gland. And it's only in areas, you basically think of your pubic areas, your axillary up under your arms, and your anogenital or pubic area. And they make a sweat that I call the stinky sweat. And it's got a mixture of sebum, which is basically sweat and fat, and a little bit of protein. And these only turn on about the time you hit puberty. So, the child's, born and goes up to about 11 years old and they sweat and they don't smell bad or anything. About 12, 13, 14, they got to start wearing deodorant because the stinky sweat has started. Well, they're going through puberty, they're starting to get hair under their arms and their pubic area. Well, these apocrine sweat glands have turned on and the stinky sweat, the sebum, is being produced. And because it's got fat and protein in it, instead of just salt, it tends to attract bacteria, and bacteria eat that, and that gives you that funky smell. Alright, they also may function as some maybe sexual scent glands because, again, they mature about the time we become sexually mature when we reach puberty. But in other animals, they do have a role in attracting the opposite sex. In humans, I don't think so. I think we just think it smells bad. You have some specialized apocrine glands. There's some that are like apocrine glands that are found in the ear, and they make earwax. We call those cereminous glands. And you also have a type of apocrine gland in the breast tissue of females that makes milk. Well, milk, basically, it's water, fat, and proteins, right? So mammary glands are basically a specialized type of apocrine gland. So we have two types of sweat glands: apocrine, which are your stinky sweat, and eccrine, which is your salty sweat. Ecrine's all over the body, apocrine just in your axillary area and genital area. The other type of gland are your oil glands, or your sebaceous glands. Again, you have these everywhere, and there's usually somewhere near a hair follicle. And again, they become active at puberty, and they make an oily type of secretion as well. And this will help soften the hair. As you get older and your sebaceous glands kind of slow down, your hair starts to dry out because they're not making that oil anymore. Let me go back to my picture. And I want to show you, I don't have a picture of an apricot sweat gland here. When I do my lab video, you'll see that. An apricot sweat gland would be associated near a hair follicle, but I'll show you that on the lab video. This gland here is a sebaceous gland. So you can see the sebaceous gland is making the oil that keeps the hair soft, so it must be associated with a hair follicle. Oh, I had a picture, sorry. Okay, so here's the hair. Here's the sebaceous gland. And if you want to look at a micrograph or a histology slide, this is actually a cross-section, and this is a hair. And here's your sebaceous gland, and it's right next to the hair follicle. And to me, it looks like a bunch of fried eggs. So if you see a tissue that's near a hair follicle, and it looks like a bunch of fried eggs, that's going to be a sebaceous gland. All right, why do we have hair? Several reasons. We have it to alert us to the presence of insects on our skin. You're like, really? Let me go back to the picture. See this hair follicle? See this hair? These are little nerve endings. When a bug crawls across your skin, causes that hair to wiggle, that causes this to wiggle, causes that nerve to be stimulated, and that allows you to know something's crawling across your skin. So it tells us that. It also helps to shield our body. Our hair will shield our scalp against physical trauma and heat and heat loss, and keep us from getting sunburned. In other animals, it can also be a warning sign. Have you ever seen a dog upset and their hair stands up on end? It's kind of a warning sign to you. But for us, it's just basically to let us know something's on us or to protect our scalp. We have hair all over our body except on our palms, our soles, lips, nipples, and some parts of the external genitalia. Everywhere else you should have hair. Hair is basically made of the same type of cells that make up skin. We have those keratinized cells. They're dead. Just like in skin, very, very similar makeup. It's very, very durable. It's a hard keratin, so it lasts a whole lot longer than your skin. Remember, your skin's basically slipping off every couple of weeks, whereas you can grow a hair for years and years and years and years. It will last a long, long time. Our hair color comes from the same thing that gives us skin color, the same pigment called melanin. If you're blonde and you've got more of a yellow melanin, if you have dark hair or brown hair, then your melanin is either a brown color or a black color. As you get older and your hair becomes gray or white, that just means you don't have melanin. Okay, it's a lack of melanin. And so what you're seeing is actually kind of air bubbles inside the shaft that gives you that gray color. The hair follicle, remember the hair follicle, where the hair comes out of the hair follicle. Again, on the hair follicle, you've got those little hair receptors, little nerve endings, and that's what allows you to know that there's a bug crawling across your skin. And you also have something called an erector pili. I've got to find, okay, hang on. I have a picture. I do. Okay, the erector pili. So here's those little nerve endings to allow you to know a bug's crawling on you. Then you have erector pili. And these are little muscles, little smooth muscles. And so they're the things that give you goosebumps. So when these contract, it causes the hair to raise up. Okay, so the erector pili will actually move the hair and cause it to raise on end. So when you get goose pimples and you get cold, that's just that muscle contracting and your hair raising up. Again, if a dog's trying to give you a warning, that's those erector pili contracting and causing their hair to stand up on end. Now, you may say, well, our hair doesn't stand up on end, and we don't use that as a threat. But we do use it if you get scared. You kind of go, ooh, it's kind of like a warning. Your body reacts to a warning by raising your hair on end. So it's kind of the same thing that's going on with the dog. And also in a lot of animals, most animals, if they're cold, that little erector pili will also contract, and that'll cause the hair to stand up, and that causes an air pocket between the skin and the hair, and allows them to have more insulation, have more air underneath the hair, keeps them warmer. So we don't have enough hair to do that, so ours is mostly kind of vestigial, but we do use it for goose pumps when we're scared or when we're cold, and things like that. Alright, where was I? Okay, and this is just a histology slide to show you the hair follicle. You can see that erector pili muscle here, so when it contracts it's going to cause the follicle to move and the hair to stand up on end. You're not responsible, don't worry about all the different parts of the hair follicle. We're not going to do that. Okay, that's it for today. I'm going to talk about skin disorders next, so hang on and I'll start that video and I will see you in just a few minutes or later or tomorrow or whenever you decide to watch this video.